Hey everyone. So I'm Chris Barker, and here we go. This is the slide deck they gave us, and we decided to leave the photos in place. So this is David Soper.
That's before I recolored my hair.
And then, as you see, I'm a solutions engineer at Puppet as well. That's my Twitter handle if you want to follow me, mostly for photos of cats and cocktails. There's a cat if you stay all the way to the end. So just the agenda, things we're going to talk about is Razor, Puppet's bare metal provisioning tool, how that works, and how we would use that. And then David's going to go into UCS and UCS policy management and using policies with UCS. And then kind of at the end are the idea of CVDs, what exactly those are, and how we can use these two tools together to help tie these solutions together. So to start, talk a little bit about Razor. Razor is an open source project that was started around 2012. It became under management of Puppet around the same time. We maintain that and develop on it. In our enterprise product, Puppet Enterprise, we actually support deploying Razor as part of your infrastructure. And how Razor works is you can build policies. And what these policies are is they allow you to define what you want to do with a machine with your bare metal hardware. Define a policy saying machines with these characteristics, this data that is discovered on the machine, what the hardware is, how is it configured. The big area that we did this on the Cisco side and working with David is actually identifying the UCS policy itself that is on the hardware that you've actually provisioned on the hardware. So instead of just the traditional Razor policies that are written around how many CPUs does it have, how much memory does it have, what does its storage look like, you can actually specifically call out a policy name that UCS is using. And then through Razor, you can also boot the hardware itself or use another tool that would start it up. Once the machine is booted, it actually loads a microkernel that has the Razor tools on it. That does, what it is actually using is Factor from Puppet, which is our inventory gathering tool. So that integration I talked about is actually a fact that is specific for the Cisco hardware to actually identify UCS policies. So it actually goes into our inventory system now. That inventory system then allows us to determine what operating system we're going to deploy on the system, and then pass that over to Puppet itself to then do the deployment of the workload that you're going to be doing on the system. So you think of Razor as the piece in between. I need my hardware configured with UCS and UCS manager, and then I need the operating system so Puppet can do its job. Who makes that decision to put the right operating system on the hardware and then pass that data on to Puppet so then Puppet can figure out what it's supposed to do with the server once it checks in and is configured. So one of the things about this is being able to abstract the workload deployment. I don't know if you want.
Sure. So to kind of step back, talking a little bit about Razor and the bare metal OS provisioning, but to back up, what we're really trying to do is kind of abstract what you're doing in deployment. And so rather than worry about all the little details and how you did something, you're going to identify a role, and that's really what you want to do. What's the purpose of what's being done? What's the need that you need to fulfill? So we'll go into a demo in a second, and that'll be demoing really the deployment in UCS, bare metal OS install with Razor, and then managing in Puppet of OpenStack Ceph storage appliance. And the key for all that is whenever you identify that role, you kind of just want to name it at the top level. And then, if you go to the next slide, as we go down into the lower levels of the abstraction, profiles are those definitions of the things that you're going to use in your role. And the profiles I'll really hit on a lot more with UCS, but the goal there is that, again, you've got an abstraction where you've created that logical definition of something, and the idea is I want to write it once, not worry about all the little details, and then I can really deploy it as needed, and I can make small changes to that deployment. And that's where I'll kind of try to, again, step back into what UCS does with really that logical representation of the things you need done. So within that role, you're going to have probably a set of profiles. Those profiles are, again, that logical representation of the workloads you're running, database, the actual file system, and then all the way down. So I think next slide hits on that. Profiles also, in the talk here, apply to the actual infrastructure. So the infrastructure is just another thing that you define logically, and that just becomes part of that high-level role. And also, same for Razor and the policies we'll hit on there. That's just another thing that you've defined, hopefully at a high level, written at once, and then you can deploy it as needed.
Yeah, and a big emphasis on this is that these are reusable components. And so now a lot of organizations already, if you're already Puppet shops, you already have these roles and profiles, you already are following this workflow, but now you can extend the profile, that idea of a role out to the infrastructure configuration as well. So while you may have written a role internally to manage your database server, that role right now is really applying to the operating system on up. But now you could also have a UCS policy that's going to say, how am I going to configure my UCS blade chassis to be a database server from the LUN configuration, the network storage, all the firmware settings, all of those things can be mapped back to that same Puppet role. So you can kind of build this kind of policy-based management that you're already doing in Puppet by using classification, using Puppet code. That same paradigm can be extended down to your bare metal hardware. To kind of go into the policy stuff, I'll let on Cisco side. There you go.
So how many folks are familiar with Cisco UCS or currently using it? Okay, so very good number. That's good. So I won't spend a lot of time, but still wanted to give some background really on UCS. And the key here, again, we'll get into a demo of Razor and some of what the Puppet folks have done to help easily deploy UCS under Razor. But with UCS, so how many folks are familiar with HyperFlex? So probably good. So to give a little background on HyperFlex, that's our hyper-converged, the Cisco hyper-converged offering that really bundles compute, storage, and networking into an appliance. And the key with it, it's kind of the gold standard for Cisco automation. And the demos you'll see on that are from rack, power on, to VM deployment in 30 minutes. And all that is accomplished with full automation under the hood. And it really highlights what UCS brings as an automatable, if that's a word, infrastructure. UCS was built from the ground up to be automated. So the low-level logical definition of what you're doing in UCS, everything is programmed into the state that you logically defined, and then you go from there. So to start with, everything there is based on a profile. And service profiles, for anybody using UCS, are kind of the key part of it. That's your logical definition of everything related to compute, network, and storage. But the profiles also are used for the actual storage piece of it. So what I'll show in just a second is our new storage server, the 3260. And storage profiles are actually at the chassis level for that server and then configured into what you needed. And then all of that is logically applied with a service profile. Within that profile, to step back kind of on that profile example in the Puppet terms for it, the profile is, again, that definition of the resources and how you want them configured. And policies actually apply the configuration. And at the low levels in UCS, those resources are all of our managed objects. And again, everything there, you set up how you wanted it, specify the exact configuration you want, and then it's programmed into that state. So a couple of screenshots coming up here. The first one is around the storage profiles for our new 3260 server. What I'll show here is in our UI, and I guess a key thing, since we're at PuppetConf, UCS Manager really is the desired state engine for UCS today. And again, everything has been done at the lower levels in an automated fashion. UCS Manager actually uses the API to program everything into its desired state. What we're working toward is doing that same thing with Puppet, really having Puppet actually have the types and providers to directly manage UCS, much the same way UCS Manager would do. But for this, this talk and this demo, I'll use current UCSM screenshots to show that. And the key is you've kind of got, the high-level abstractions of resources, and then when you get down into a resource, you go create a profile. And as Chris was mentioning, this goes into your actual LUN configuration, the disk groups, et cetera. And the key there is you don't have to have, there's not other interfaces to do this. You're not messing with store CLI or something else for a mega RAID controller. It's all done in UCSM. And under the hood, again, it's all that API-backed configuration of UCS. So that's the infrastructure for UCS. Going into what you do for deployment, this really hits on where Razor comes in for that OS deployment and kind of builds on that. And the key thing here, for OS deployment, traditionally in a lot of setups, you have to go in and kind of specify which MAC address or other hardware you need in the deployment. So your PXE server or other environment, however you got that set up, probably is matching on, could be matching on a MAC address. With Razor policies, you can up-level that to which CPU, how many CPUs I have, how much memory I have, what's the storage, et cetera. And what the folks at Puppet have done with the Razor and UCS is really tried to simplify that where just give it the name. Have something meaningful in terms of that role that you're deploying. Which OS do you want deployed? Get that information from a service profile and then apply it in a Razor policy. So these are probably not the best examples because it's not really tying into a role, but to keep it in something easy to understand, the name of my policies are just the OSs I want installed. Windows 2012 R2, CentOS 7. And the way I match that with a tag is actually just going to be a service profile name. So when I do that service profile in UCS Manager, that matches a tag. And there's a lot of flexibility in that tag matching. And that's what OS gets installed. So I have just in my profile basically specified what OS I want, and then Razor will handle installing that based on its policies. A lot of flexibility there as well in terms of how you hand it off to Puppet into a role directly. So this process, other information basically gets passed up during that handoff, and you can essentially auto-classify it into a role all the way into Puppet.
And one interesting use case you can start doing with this is if you want to actually test on bare metal side and actually use the storage policy on different systems that, you're going to test on a blade that not allocate all the storage to it or all the network interfaces because it's a development environment for your bare metal space. Instead of having to rewrite your Razor policy because your Razor policy now used to be, I'm going to match this on 4 cores and 64 gigs of memory and all this other stuff, you can say, well, I'm still going to deploy my CentOS 7 Ceph storage development profile on the system, and Razor will just pick out, well, I'm still going to do CentOS 7, I'm still going to do Ceph storage, but I'm going to throw the devs tag on there as well, and not have to fidget with the, okay, well now I have to have a separate policy for my 4-core versus 2-core versus 64 gig of machine. I can kind of keep those policies fairly static and just run, on the Razor side, run machines through it and then change the variables by changing the policy names on the UCS side.
And how many folks are using Razor today for deployment? Not very many? Okay. How many are using PXE in general for any sort of auto-deploy setups? Okay.
And for those who are using PXE and haven't looked at Razor, Razor is still PXE. I mean, the big thing about Razor is we don't provide a PXE server. You just give it a different microkernel to boot through PXE, and it just knows how to phone home to the Razor server and run the policy engine on the system locally. So if you already have a PXE infrastructure, you can use Razor as part of it.
So switching a little, I'd kind of gone through the abstraction and how you'd program all that. Somewhere along the way, you still needed to know what to actually do. So we got a question kind of before the talk on that service profile once you set it up and it's running, remembering what you actually did and how you configured all that. The idea is, you kind of touch it once and then maybe you don't touch it again. And that's where longer term we'll get Puppet in to do it. But the other challenge in all that is how do I actually set this stuff up? So in this example of a OpenStack Ceph storage appliance as part of a cluster, how do you actually go configure that? Where's the instruction manual I'm going to follow to do that? And this is where Cisco really provides a lot of resources on validated design. So how many folks are familiar with Cisco validated designs? Yes, although it's very broad. So the question was, is that like FlexPod? So FlexPod is one of our NetApp, or an integration with NetApp storage. And along with a lot of the other storage vendors, what we do is actually create a validated design using those partner appliances or any other pieces of software, and then rigorously document what it is. So what this really hopefully allows folks to do is to get back and kind of focus on, again, that deployment and ongoing management of it instead of how did I set it up, how do I remember how it's set up. So Cisco kind of does the heavy lifting here of creating that instruction manual. Somewhere you're going to have to know what you had to do. If you're setting up an OpenStack cluster, that's challenging. You could go Google OpenStack 7 or whatever version you want. Who knows? That's kind of instructions of unknown provenance. So if instead you Google search OpenStack 7 Cisco validated design, there is an OpenStack Cisco validated design. And these are big. So this one's 351 pages. That's a lot. But this covers the full implementation of OpenStack, from everything in terms of exactly how you configure service profiles, all the networking with that, all the way down to BIOS policies, and then the switch infrastructure above it. This example is the Nexus 9000 switches, everything related to their configuration, the storage for it, all the way through what you're actually doing in OpenStack. So all the OpenStack deployment instructions, the versions of the OS, et cetera, are all in there. And the goal here is that it gives you kind of that template to start from, and from there you can automate back to that idea of, I just need it to do this thing. I need a Ceph storage node. Help me write that once, adjust it as I need it down the road, and keep it under management with Puppet. This is something we're kind of trying to work more on, is that ongoing management with Puppet. Part of these designs are, yeah, you set it up with OpenStack and our managed OpenStack cloud, MetaCloud for Cisco. Puppet actually is the management engine there, but the idea of getting that back down into the deployment so that you can do ongoing management of the infrastructure is something we're working to kind of help. Ideally, this would be in some sort of automation form instead of a 350-page document you have to read.
Yeah, one of the ideas to think about this is you get one page, and that page says run Puppet, and it will get you those settings that you need. Because as someone who's also gone through these CVDs, a lot of them are literally fill in what is the subnet range you want to use, what are the things that you need to, pretty much anybody who's been writing Puppet code, what are the parameters that you need, the top level parameters you need to pass into this area, but we'll handle ensuring. The rest of it is make sure port 1 on your Nexus 9K here is set up with these settings to talk to port 1 on your other Nexus 9K with these exact same settings. Make sure your storage has these IOPS dedicated with this fiber channel LUN back to this system. All of those things are pretty much going to be the same. The only things that you really need to change are like, what is your site-specific data? What is your domain name? What is your internal IP ranges you want to allocate to this hardware? Those are the things that are user configurable. And right now, inside here there's a lot of copy-paste into command lines to do this. But we also have integrations with the Nexus switch. So why not do a Puppet code to just configure the switch the way you did? If you haven't seen the exhibit at the Cisco booth, they're actually showing the VXLAN being deployed on all the Nexus 9K switches to a specific topology using Puppet. So this is the area we're hoping to go forward.
Yes. And did anyone go to the talk yesterday on Cisco's application-centric infrastructure? So quick recap of that one. That one's ACI and really the Nexus 9000 infrastructure. A lot of it is built on UCS type technology. Define a profile, apply it to the hardware, and it's really that infrastructure as code is the buzzword we always like to use. But the key for that really is that automation capability of that versus the traditional Cisco network switch setup of command line, and you've got to be a CCIE who's had years of training to go configure it. How do you do all that switch port and all that other setup with a CLI? The idea here And really what the Nexus line is kind of already done with Puppet is, I don't want to have to know, I don't want to get buried in the details of how do I actually do that. I just want to manage that setting, have it applied, not worry about it. And that's what we're working toward on the UCS side as well. And again, the bones in UCS are all there. That's the same thing that Nexus and the 9K switches are built on in ACI. But UCS Manager already does so much of that. Now we're kind of opening it back up for other solutions. So now to switch gears to a demo of this, this is really showing our configuration in UCSM again, but then getting into that Razor part of it. This first part is highlighting some of the configuration of our storage server. So this is a live configuration, well, it was live, of our new 3260 storage server. And just for some overview of that server, that's a high-density 4U server that's configurable in 1 or 2 two-socket servers, and then up to 60 large form factor disks, SSDs or spinning disks, and really cost optimized. So that density of storage in the large form factor really keeps price down, still as a high-density server. The key with UCS and what differentiates it a little bit, a couple of things. One is performance aspects of it, very good. The management of it is all from the API. And here's the web UI doing it, but on the back end, it's all the API. So my 60 disks in the chassis, I can zone to either of the servers. I can change that as I need. And then I can go create storage profiles to actually manage that configuration. So back to the Ceph storage appliance, what we're doing in storage provisioning here is going in and actually creating that Ceph storage profile per our CVD to create my boot LUNs, assign disk groups to that, actually do the RAID configuration. And all that is done in a profile, basically created at once, have it logically applied, and then the storage is kind of realized on the back end. And I will speed this up just a little. Whoops.
The joys of trying ways to save yourself on doing demos.
Do you have any of these modules on GitHub or Puppet Forward or anything for UCS?
So there are some open source ones. We're currently still working our initial implementations of actual UCS management. And I'll show you in the next demo one of those. So skipping ahead on this one a little bit, the other thing that we did there in the service profile that I ended up skipping over, back to that earlier slide, we just named it CentOS 7. That's going to match a Razor policy as Razor comes up. And then, again, the role we really created is that Ceph storage appliance. We've told Razor to boot CentOS 7. It'll do that automatically based on the service profile name. And then once it comes up, it actually will go under management within Puppet. And so that role then in Puppet would be of a storage appliance. And you can do the rest of the configuration in Puppet. So all those pieces, again, are just part of a role. And the profile to do all that is between your UCS and all its profiles and policies, Razor policies to control OS, and then typical management in Puppet after you get it all assigned.
Yeah, and again, we're trying to think of this as ways to really automate and rapidly deploy your infrastructure. The other areas of interest that I've been working on at Puppet has actually been in the cloud area. And so talking with David about this, it's really like, when we talk about people deploying stuff in the cloud, they're like, just tag the server that you wanted to, boot it, and then have Puppet figure out what to do with it. This is kind of giving that to your bare metal hardware as well, just being able to tag this box with a service profile that's going to handle optimizing disk, optimizing storage, attaching it to the right VLAN, and then you can deploy your actual application on it in the same way. So there was like during the DevOps panel yesterday, they were talking about like how can you get DevOps and agility to areas that traditionally aren't, people don't assume as DevOps capable or agile or nimble, because you can't do this with bare metal. It's like, well, you can. There's this tooling here that's allowed you to do this for a while. We're just trying to expose it and give these workflows that allow you to really quickly, dynamically deploy stuff. And after this, actually, on the same chassis, we can actually cut to that a little bit.
Oh,
Is-
there's the correct control.
Yeah,
If you go just a little bit.
here.
So that was magic. It was like 1 minute and CentOS was installed under Puppet Management. Exact same physical hardware. Now I'm going to go switch the profile out and change it over to a Windows 2012 boot. And I'll switch that profile. I'll switch the storage over to a different storage setup. And again, all managed from the API, all managed objects under the hood. So I'm going to switch off of my Ceph storage profile for this Windows 2012 service profile. I'm going to switch over to a PCH managed boot infrastructure. That PCH I'm going to set to RAID 1 and basically configure the controller for RAID 1, all from within UCS. And then as soon as I finish this, I'll go reassociate my new Windows 2012 service profile with the same physical hardware. And under the hood, UCS switches all that out, erases essentially the memory of that Ceph storage appliance, switches me over for Windows 2012 boot off of my PCH local LUN, which I've configured, and then brings it up and Razor provisions Windows this time. Same physical infrastructure, completely different logical identity.
Yeah, so in this area too, you can think of this as you can have a server that's spending the morning as a Red Hat box, and then the afternoon it's going to be a Windows box. Just being able to reuse your physical hardware without having to run anybody out to the data center, without having to do any management on it. You just push a different profile to it, reboot the box, and you get a new system. There's other organizations that have been using Razor as part of this for a while, where they're doing development for Hadoop, and they just need to be able to, they want to do bare metal testing of Hadoop for performance, reboot the box, go in there. One of the things that Razor does let you do is you can actually have servers that are booted in Razor and they're just stalled. They don't yet have a policy applied to them, so you can actually have a list of servers that are in idle capacity. So for one organization that was doing Hadoop testing, and we now have a Windows box install.
That's right.
Deploying.
It was like 30 seconds. That's even faster than OpenStack.
But we now have this Windows progress screen. I was telling David earlier that the Windows progress screen is a little bit more visually appealing, that it's actually like, and everyone's familiar with the Windows install screen, I'm sure, as you've watched it for hours. But the idea of being able to say, as a developer, I have a bank of physical machines that at any time I can reboot into a specific operating system and run my test environment on from bare metal, so that when I actually go to production, if that's also on bare metal, it will work. Instead of the works on my laptop, works in Amazon, works in OpenStack, works in VirtualBox. But for some reason, we can't figure out why this is terribly low performance on the actual machine with 64 cores and 128 gigs of memory. You can actually kind of even add that flexibility to the environment.
So the Windows, that's kind of the end of that demo. We could probably just switch to the next one. And so this is kind of a proof of concept of managing UCS within here. And the key thing, this is not at all how we would implement this for real. It's got the dreaded exec using one of our actual command line utilities. The simple thing here was this avoids some of the things we don't really have implemented from a Cisco point of view, which are the proper types and providers to directly manage UCS. So this is an easy way, using some of our other settings, to go manage actual BIOS or other policy. This is actually all possible today. We use this in some environments to manage things directly from the host. One of your options is actually to manage completely from booted host and not worry about interactions with the management plane. But the thing I wanted to highlight here is really whenever we're talking about infrastructure management from Puppet, what's kind of the end goal of that? So very easy to understand what you want to do in terms of your OS stack, the services and everything else, and what Puppet does. From the infrastructure point of view, just like anything else with Puppet, this is helping manage centrally all your configuration settings. And in this example, I have a make-believe node in a given role, and this is a high-performance one. So what this demo is going through is I'm setting up an application one high-performance group, classifying nodes in that. And for example, if I want hyper-threading disabled on that, so in this make-believe example, this application's very optimized once hyperthreading disabled. And from the console in this example, you go say, I want hyperthreading disabled in my infrastructure. And then the goal is that setting is maintained in the infrastructure. So as this demo goes along, it uses that UCS module to ensure that setting and can do drift remediation on it. I guess a caveat there, obviously you want to be very careful in how you actually implement that. In this example, it does reboots when it finds the configuration drift, which would be quite disruptive, but a lot of flexibility there in how you do it, and that's kind of the intent of that infrastructure configuration management. Great question. Sorry, I didn't clarify that. And this is for the types and providers we're implementing, it's all API-based. And there's quite a few other examples of that, especially coming into existence now within Puppet. But we would not run an agent within our infrastructure. It's instead API-based management with the UCS API, which is kind of the foundation of all of the setup. Our switch management is also moving that way. So there was a talk at some point showing some of the recent integrations with Nexus based on Netcomp and using more of that API-based management, and UCS is following a similar model.
Yeah.
We script the fabric interconnects so that do, say, firmware updates to the local blades.
So the question was, can we script the fiber interconnects for fabric?
Control the blade servers. We want to be able to talk to the blade servers and get them to do a standard, firmware update, which is very time-consuming task right now.
Yeah, so doing a
Yes.
fabric, yeah.
And the
firmware
question
update.
was around firmware updates, and UCS, supports that very seamlessly. Again, back on the profile, what you do there is actually create policies for the host firmware packages, which are your firmware packages, and then UCS really handles the rest of that. And same here, that would really just be another parameter. What version of firmware do you want? And UCS helps ensure it's at that version. And as with any firmware update, that workflow is kind of up to you on how you do it. Do you want that update applied immediately? Do you want it applied on next reboot? How do you want it done? Those are all other policies that you specify within UCS.
Just kind of as a review of what we were just talking about, the idea of being able to configure your hardware with a software-defined policy, be able to configure the handoff between your hardware to an operating system with a software-defined policy. Once that's in Puppet for the operating system area, being able to have that drift remediation to keep that machine in that known good state, being able to apply all of the other things I'm sure you guys have been seeing about Puppet in today and yesterday on that hardware, on that operating system, and then extending those up to the rest of the application stack. The next area, again, what we kind of showed in that last bit was trying to find out the use cases to help us build out how we want to do those types and providers to extend Puppet to then manage your UCS platform itself. So you'd actually have a full loop back between Puppet being able to push configurations and manage the state of your hardware that then correspond to deploying service profiles for the hardware configuration that then maps to Razor profiles to put the operating system on it, that then goes back to pretty much a actual application server that's running on that hardware. Really so that we can get to that point of that one-page CVD that says run Puppet. So give us the addresses of all the UCS hardware that you want to turn into this component, and really that's the area we'd love to get to, is that true, being able to go to the area of I need more storage in my OpenStack environment. I just get the hardware, plug it in, point Puppet at it. It's going to push the profile you've already tested on it that you know is the same across all the other systems in your environment, and be able to get it the same operating system on it and then the same OS configuration on up. So you're not sitting there wondering, why are half of my VMs underperforming? It's because, oh, we forgot to turn on this IOP setting on this new chassis we installed because Bob forgot that page and the manual was stuck together or something, which, still kind of vulnerable to the user input error around these things.
So how much is anybody doing kind of that infrastructure management from Puppet, things like BIOS settings, policies, management controller, firmware? Anybody currently doing anything like that in the infrastructure?
So I'm managing basically all our Razor stuff.
Okay.
Okay.
But yeah, it'd be really great to basically have it integrated so we basically define a system once and it does everything from UCS to Razor to basically getting it connected to Puppet.
Okay. And so there's definitely some challenges, I think, within that infrastructure management because, again, it's the infrastructure, so that drift remediation and other things can be a little more disruptive. But really what we're after there is giving them the flexibility to do that. And then also, at a minimum, understanding when change has occurred. So back on firmware, if that did change, you've got a desired state of firmware. You might not go in and automatically update it, but you could at least say, hey, that's not at the version, and I didn't do it. Those are the sorts of things that obviously Puppet's very good at.
How about getting what you currently have in there? Is there a way to take out, extract out what your current profiles are and get that into, or are you working on it?
So the question is, how can we extract this information?
Right, so what we have now is not in Puppet, but we want to get it there.
Great.
But we want to get it there, so we're not starting new, we have existing.
Yeah, so in that case, that's really, I think, kind of the design value of having a tool like Puppet looking at this environment, because if we implement the type and provider properly, Puppet will be able to enumerate the current state of the system, and this is how Puppet works whenever it is actually managing a system. It is always enumerating the current state, and then applying the catalog of what the intended state is, and then making those changes. So in theory, you should be able to do Puppet resource UCS chassis name, and it would actually return back code of what that state of the system is. If you have a Puppet, if you've not done this, and I've realized a number of people who haven't actually done this before on Puppet, you're on a machine with Puppet installed on it, you're an admin user, run Puppet resource user, and you get a list of all of the users installed on that system in Puppet code as Puppet sees it. Puppet user package, service, any of those types, if they're defined properly, and almost all of them are, because especially if they're coming from us. Otherwise, it's literally a bug. If that doesn't happen, it's actually a bug in how Puppet should be doing this. So I'm kind of holding David responsible to make sure that UCS does it this way.
It
Then
sounds
you
like
can
to me,
do it.
but get to blame him.
Yeah.
So that's not my problem.
But that also gives us that,
It's interesting, you should be able to point to that and give me back.
yeah, exactly. We had a gentleman I was talking to yesterday, had a machine that was set up by a VAR with UCSD, but that was the only one set up that way. And they have no idea, they don't actually have that service profile. They have no idea how to get the data off of it to do it. And this would be, in a way, to extract that with the right APIs. Before we run out of time, there's the cat photo for everyone. It is not a slide, it is not a DevOps or IT or thought leader or whatever talk if there's not at least one cat image.
That's right. This way we get to keep our engineering titles by
Yeah.
not showing professional slides. Back on that topic of, I was just going to wrap one thing and then definitely more questions, and we have 9 minutes left. For kind of what you currently have and what you could do with that programmatically, UCS, any sort of backup operation, that backup file is just an XML file with managed object state. That's all that's in it. Everything in UCS is that managed object. And that's really what, again, we're working to get into Puppet is just managed object management. So pretty straightforward file to parse and do something with. And then that really captures all your state. And we use that in a lot of other automation frameworks today. So from those backups today with Power Tool or Python scripting, you can actually go basically recreate a script to do that. So similar tools for whatever other kind of automation framework you're using are definitely possible. Go ahead, I had a question there.
And just one
Thanks
thing,
for using the mic.
one thing to add on to that, that configuration state extraction allows us to do that no-op in simulation mode that Puppet has. So
We use the simulator, the UCS simulator against this. So if we stand up the simulator.
in theory, yes, but let's go on to the next question. Yeah.
How does Puppet communicate with the API? Does it use a proxy node and
Yes.
Using Puppet device?
Yes.
Yeah.
I'm guessing you add the UCS or the FIs to Puppet.
So right now it's not, we probably won't be under Puppet device, but it would be a system that would have the credentials to log into UCS Manager. Right now, the thing with Puppet device is it handles each device separately instead of possibly wanting to be able to coordinate a group of UCS machines in one Puppet run. So it's kind of, How we've been managing remote services recently has been like with NetConf Yang and Amazon is the machine has the credentials to then connect in on those and allowing you to kind of have multiple UCS chassis in there or UCS Manager itself as the endpoint. And so it's able to work with it that way. So we're still in the early design phase of what that's going to look like, but in terms of under the universe and the wrap of how Puppet is managing things that we don't have an agent on, that's our goal.
Are you considering accessing like UCS Central instead of UCS Manager?
So yes, and Central, another great thing, for folks not familiar with it, UCS kind of comes in 3 flavors here. We have standalone, not UCS managed, and then UCS managed, which brings in the fabric and all the ideas of logical servers, and then Central above that, which brings in multi-domain management and global policies. The great thing with all that is it's the same unified API framework. Obviously, you're going to be talking different endpoints, but all that idea of managed objects and how you would interact with it and manage it is the same. So if you want to do global level management in Central, you can do the same thing, and there you have the advantage of one endpoint to connect to, and then a full managed object namespace from global all the way down to the server level to manage.
So I've built a cluster of machines at this point with Razor, and say they're all acting as a single unit. So I'm mostly in the vSphere world, so for me, maybe this is like a big vSphere cluster. And now I want to orchestrate some sort of rolling upgrade of vSphere. I put in a new image into Razor, and now I want Razor to be able to orchestrate that upgrade for me. Is there a way that could happen?
Right now, Razor doesn't have any sequencing in it in terms of deploy, reboot a server A, and then reboot server B, and then reboot server C. That'd be something I think we would want to look into really on the orchestrator area of handling the dependencies of building that out. Right now, an area that our orchestrator team is working on is how do we handle that infrastructure level changes? Because the application orchestration idea right now is I have a fleet of machines and I want to slice them up into certain ways and manage them, but we don't have I don't yet know about a machine, but when this machine shows up, I need to do stuff with it, and maybe I should create that machine. I would say if we go down that level of detail to solve that, that would be in that area. On the vSphere side, I just do know that there is as someone who was at VMworld recently, the SDDC manager, which is kind of their tooling to do that. And so that's on a separate track. We're talking about having possibly Puppet interfacing with the SDDC manager to help manage that rollout for you.
It sounds like you guys are on the right track to, integrate Puppet and UCS and put UCS management on the Puppet, right? When can we expect to see like a module that we could use and basically, is there anything we could use today or, sometime next quarter?
So there actually are some examples out on GitHub that have been community developed. We're working toward like end of the calendar year, although those dates are very flexible. I guess don't hold me to that one. But that basic managed object model on GitHub with a Cisco supported implementation coming fairly soon.
Okay, thank you.
Any other questions, or I think that's it. Thank you for your time.
Thank you all very much.